Okay, we continue with unique least square solution for best approximation. Okay, example 1. We want to find the least square solution where the least square error vector and the least square error of the linear system. Remember, what is least square error vector? We have studied before. Okay, if we go before, the least square error vector is, what is the least square error vector? Okay, let me see least square error vector. Okay, least square error vector is b minus ax. Alright, and least square's error is the distance of b minus ax. So now we want to find this vector. Okay. Okay. So how to solve this? So firstly, we write the solutions in matrix form. Alright. So you can write A in matrix form and B in matrix form because you have to change in the system of matrix in the terms of AX equals to B. Okay, where we have, okay, and then we use the transpose A transpose A. Okay, by formula A transpose A, we get the value of 14, -3, -3, and 21. Okay, and then we find A transpose B from the formula we have studied before this. Okay, A transpose B, so you will get 110. Alright, and then from the formula, we know that A transpose AX is equals to A transpose B. So, by using the formula and by using the equation that you get before this, we found that this formulation, the normal system is equals to 110. Okay, so from this equation, from this matrix, okay, we want to solve the unique least square solution. So we from here we can find the value of x. Okay, so we find the unique least square solution. Okay, how to find this least square vector, error vector? So we know that we have to find the least square vector, we have b minus ax. Okay, so the value of b just now, we minus with a times the x. Okay, the value of x that we get just now. Okay, and then when we calculate, we get the value of b minus ax. So this is called the square error vector. So we answer the first question, want to find the least square error vector. And then how to find the least square error? By finding the distance of b minus ax. Okay, I hope you still remember to find the distance. Alright, the distance. Okay, then you can get this answer. Okay, so find the distance and then find it whether you get the answer. Alright. Okay, let's see example 2. We infinitely many least square solution. Find the least square solutions error vector and the least square error of the linear system. You want to find the least square error and least square error vector. Okay, so as we done before this, you change into the system of ax equal to b. Okay, and okay, you get ax equals to b. Alright, so when you change the system, you will get this one. Okay, we actually this is one more equation, x1 plus 10 x2 minus 7 x3 equals to 1. Okay, there one more question, so that you will get the form of the matrix like this. Alright, and b equals to 2, -2, 1. Okay, it follows that you have to find the A transpose A and A transpose B. Then when you have get the value of A transpose A, put the augmented, find the augmented matrix of the normal system. Okay, alright, so you use the row echelon for this matrix. Okay, so I will not show here because you have studied for this of the row echelon form. So find if I let you find the answer of the row echelon and try to solve this question and found that if you have this answer. Okay, from which it follows that, so where you get this answer, will get the value of x1, x2 and x3. Okay, so let's check. Okay, let us verify that all the least square solution produce the same least square error vector and the same least square error. To see that it is so, we first compute b minus ax. So when you compute b minus ax, you will get this value. So when you put the value, when you get the value here, you can find least square solution produce the same error. Okay, you get this answer for error vector. Alright. Okay, if A is m times n matrix with linearly independent column vectors for every m times 1 matrix B, the linear system AX equals to B has a unique least square solution. This solution is given by X equals to A transpose A inverse A transpose B. Moreover, if W is the column space of A, then the orthogonal projection of B on W is called projection B on W equals to AX, where A times A transpose A inverse times A transpose B. Okay, example from the formula before this and the matrix in formula 7. Okay, formula 7, this is the matrix in formula 7. Okay, this is formula 7. Okay, we want to find this formula 7 and formula 8. So you are given this matrix, you want to find the least square solution of the linear system. So find the least square solution of the linear system, we use this formula. Okay, so you just put the answer, the value in this formula. So you know that just now A transpose equals to A transpose A equals to 14. Okay, 14. So you put here and must have inverse. Alright, times A transpose. Okay, you transpose A times B. So you have B here, put here, and then you can calculate as usual, and then you will get the value of x. Okay, this is one of the formula solution by using least squared solution. Alright. Okay, so that's all for today. Hopefully you will understand of the approximation by using least square. Okay, see you. Assalamualaikum.